All right. So I've done a little bit of work now in our exercises, finding trig ratios of various angles bigger than 90 degrees now. I've noticed that the signs change depending on where I am on the coordinate plane. And finding them by hand every time is a lot of work, right? So I want to build out a reference for finding trig ratios, which is what this is. It's something that I can reference. I can look these things up. And this reference is called the unit circle. And that word unit means that the radius of the circle is 1. That doesn't seem that important now, probably, but it will be important as we fill this out, okay? So what this allows us to do is derive any trig ratio that I need. And the last thing that it's important to remember, I was just told to memorize this when I was a math student, when I was a pre-calc student, but it's actually important to remember is it's just made of special triangles. So it's made of the triangles we already know. So you actually don't need to memorize anything as long as you know how to build this thing. And that's what we're going to focus on here. So I want to show you what I mean by that by drawing in a couple of these triangles. And then we'll talk about how to fill this out more completely, and I'll leave you to tackle the rest of them on your own. So let's do 60 degrees. So there's my triangle for 60 degrees. And we will let's do a negative one, we'll do 135 degrees. So there's my triangle for 135. So one thing I told you is that the radius of the circle is 1. So any hypotenuse for all of our triangles is going to be 1. And then I told you that these are special triangles. So this is obviously a 60-degree triangle here. And 135 is a multiple of 45. So this is going to be a 45, 45, 90 triangle here. So we have to figure out the remaining sides. And luckily we know all the math to do that, right? I'm going to draw a couple of models that might be useful as you fill this out, and I suggest you add these to your notes. I'm going to draw them down at the bottom here. The first we'll do our 30, 60, 90 triangle. So we drew it like this, a 2a, a square root 3. And remember, this side was your 30, other side is 60. And I just told you that my hypotenuse is always going to be 1. So let's solve out the rest of our sides for this real quick. So if my hypotenuse is 1, how do I want to do this? We'll say 2a is equal to 1. That means a is equal to 1/2 when I solve that, right? So we get 1/2. And then this side would be 1/2 square root 3, or square root 3 over 2. Right? So there's a nice little reference triangle. And it's going to match our triangles from the unit circle. And then my 45, 45, 90 triangle, let's draw that a little bit better, huh? Well, that's going to be a square root 2. And I said my hypotenuse, again, was 1. This one's a little bit harder. So a is going to be 1 over the square root 2. Or when I rationalize, square root 2 over 2. And you guys know how to do that math. I just multiply by the square root 2 on top and bottom. So both of these short sides are square root 2 over 2. All right. So these models are going to be super important as you go to fill out. Let me show you why. So notice my right-hand triangle, my green triangle, is this 30, 60, 90 triangle, right? And I just found that my long side is square root of 3 over 2. And my short side is 1/2. This means if this is a point on the coordinate plane, this is the point, what is this? 1/2 comma square root 3 over 2, right? So x comma y. Same thing here. I just found my hypotenuse is 1, and then both of these sides, square root 2 over 2, square root 2 over 2. One of these, however, is negative. My x value is negative. So if this is my point, negative square root 2 over 2, comma, square root 2 over 2. Okay? So you probably followed that, but like maybe it doesn't mean a whole lot. You're like, so what, right? Well, let's say I want to find sine or cosine, right? So remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. But my hypotenuse is just 1, right? So this is why this is so useful to us, because that just becomes, well, sine is opposite, cosine is adjacent, right? And really, what that means here, my opposite and adjacent sides are just my x and my y coordinates, right? So here we have cosine and sine. Here we have cosine and sine, right? So as I look around the unit circle, and your next move is going to be to do a little bit of practice on this and fill out this entire thing just by drawing your triangle. That is also what your mastery is going to be, is just deriving this by hand. So you don't have to memorize this if you understand how it works. What you get, and I'm only going to show you this briefly, is a reference where you can walk all the way around the triangle, and every x and a y coordinate is a sine or a cosine of a particular angle you might want to find, right? So this is, again, it's like our multiplication chart, but for angles. And again, I was taught to memorize this. I don't think that's the best way to do it. I think the best way to do it is in your notes, complete this by hand, deriving each and every angle, paying attention to the patterns. So notice we have a pattern that repeats with the same signs. And then when you need it, you can build it by hand, right? So you don't need to memorize this if you understand it deeply.